In this video, we will discuss determining the normality of a data set. Normal distributions are important since many statistical methods require that the distribution of values be normal or approximately normal. There are many ways to check for normality. The easiest is to draw a histogram for the data and check its shape. If the histogram is not approximately bell-shaped, the data are not normally distributed. We can also check the skew of the data using the Pearson coefficient, PC. The formula is PC equals 3 times the average minus the median over S. If the index is greater than or equal to +1 or less than or equal to -1, it can be concluded the data are significantly skewed. There's a third method of determining normality, and that is checking for outliers. If there are outliers, it is possible the data is not normal. For example, a survey of 18 high-tech firms showed the number of days inventory they had on hand. Determine if the data are approximately normally distributed, and here are the data that are involved here. So the first thing we do is construct a frequency distribution and draw a histogram for the data. Here's our frequency distribution. And here is our histogram. And it's basically bell-curved. It's higher at the center and tapers off to either side. Since the histogram is approximately bell-shaped, we can say the distribution is approximately normal. We can also check for skewness. For this data, X bar is 79.5, the median is 77.5, and S equals 40.5. So the Pearson coefficient is 3 times 79.5 minus 77.5 over 40.5, which is about 0.148. It's not greater than +1 or less than -1, so it can be concluded that the data is not significantly skewed. Finally, we check for outliers. Recall that outliers are data values that lie more than 1.5 interquartile range below Q1 or above Q3. Here, Q1 is 45, Q3 is 98, and the interquartile range is 98 minus 45 equals 53 units. An outlier would be a data value less than -34.5 or greater than 177.5. In this case, there are no outliers. The data set is approximately bell-shaped, the data are not significantly skewed, and there are no outliers. So it can be concluded that the distribution is approximately normally distributed. We'll do one more example. Here is the data consisting of the number of games played each year in the career of Baseball Hall of Famer Bill Mazeroski. Determine if the data are approximately normally distributed. And rather than repeating all of the possible methods of determining normality, we'll focus on the Pearson coefficient. I will note that the graph does not look terribly like a bell curve, so there's that too, but we're focusing on the Pearson coefficient. For this data, X bar is 12.725, the median is 143, and S is 39.87. So the Pearson coefficient is -1.19. And since the Pearson coefficient is less than -1, the distribution is significantly skewed to the left, so it's not normal.